All right, I hope that the last lesson was okay and you managed to kind of get the feel for solving log equations. This next group of questions has to do with applying logs. So rather than just be given the numbers, it comes from a word problem. Yay, everybody's favorite word problems. Yeah, no one likes word problems. It's funny that in math, people don't like word problems. That's my opinion too. Keep English out of math. I like solving math questions, not English questions. Anyways, this is a bit of a strange lesson because I don't think they're fair, a lot of these questions. So here's what's going to happen. You're going to be given a scenario, a word problem, and then it'll give you a formula. Now, the first couple formulas, you might have even seen those before, but there are many different formulas. And many of them, you don't really understand the context of the question, but we're asked to solve using logs. So what this is going to mean is you're going to be given a question, you're going to plug in some values and have to solve usually for a value in the exponent. Okay? So we're going to work through some of these, but I'm going to make a sort of a generalization here. On the practice test, there will be some of these questions. You should try to learn them. You should try to be able to do them. But when I give you a test this year, we're going to stay away from the word problems. Okay? So the questions I ask you will not be word problems. All right, so if your only concern is your mark, then you maybe don't want to do this. If your concern is understanding math and that you want to be prepared for what comes next year, then make sure you do these. All right, let's get into it. So applying logs. So the first one, this used to be part of the course, this one, this formula, compound interest. The idea with compound interest means, like, for example, if you put your money in the bank, not only are you going to collect interest on the amount you put in, but after it's accumulated, you'll get interest on the interest and then on the interest. And that's why it's compounding. It continues to grow and grow more than just getting a certain amount on your principal interest. Okay? And this used to be a formula that was part of the course. Now it's just one of the possible formulas that could be on the evaluation. Okay, so these two formulas are the same. They just have slightly different numbers. Usually this is the more common one. Okay, and whenever you're given a new formula, you'll be given this information. What do each of the variables represent? Okay, A is the final amount, P is the initial amount, R or I is the rate, the interest rate, N is the number of compound periods in a year, and T is the total time. Okay? So that's the formula. Let's try a question. So it says a principal of $1,500 is invested at 4% annual interest. Here's the sort of the clue that tells you we're using that compound interest formula. So let's write it out. 1 plus R. Okay. And there's an N there, and then NT. Okay, it says the principal, so that's the 1,500 goes for P, is invested at 4% annual interest. So there's 1. The interest rate is 4, but don't put 4. You're always going to put it as a decimal. Okay? And then it says compounded quarterly. Quarterly means 4 times a year, so there are 4 periods in the year. So N is 4. For how many years? 7. So this is just put it in the calculator. Okay? Let's grab a calculator. Let's put the whole thing in there. 1,500 times, open brackets, 1 plus, and you can actually just type this in exactly as you see it. So 1 plus 0.04 divided by 4, close the bracket, and then to the power of, don't say to the power of 4 times 7. Say to the power of 28. Okay? Otherwise, your order of operations will mess you up there. Okay, and since it's cents, we go to 2 decimals. Okay, so just highlighting what I mentioned there, make sure that you want it to be to the power of 28. If you put in your calculator to the power of, and then you go 4, and then you press times 7, it's going to do this power first and then multiply everything by 7. That's not what you want. Okay, so that's a pretty simple question. You don't need logs for that one. Let's try one now where the you will need logs for. Okay, so it says a principal of 1500. Oh, so this is another question using the same formula. Okay, now principal is 1500. Okay, so that goes here. Is invested at an interest rate of 2.25. So I go 1 plus, and what do I put here? 0.0225. If you're ever wondering how to get this, just divide by 100. Okay, so take that amount, divide by 100. Okay. Compounded monthly, so that means 12 times in a year. And to the nearest quarter of a year, when will the amount be 2,500? Well, that's odd. This time I don't know what t is, but I do know what the final amount is. So the question here wants us to solve this. That's a variable in the exponent. This tells me it's going to be a log question. Okay? So if you can solve this equation, you can do all of these questions that are coming up. All right? What kind of question is this? Well, there are no logs. The bases can't be made the same. This is a question that we're going to take the log of both sides. Okay? So I could start by taking log of both sides. But if you remember the last example I gave you yesterday, sometimes you can divide by this first. Okay? So I'm going to divide this side by 1500, and then I have to divide the other side by 1500. Okay, so I'm not even going to figure out what this is. I'll just go 2500 divided by 1500. And this then becomes 1 plus 0.0225 over 12 to the power of 12t. Okay, now take log of both sides. So log 2500 over 1500 equals, and if I take the log of the second side, that allows me to put the exponent as a coefficient. Okay? So how do I get t by itself? Well, let's highlight where is the t. Here's the t. I want it by itself. So what I'm going to do is divide by 12 times log 1 plus 0.0225 over 12. So divide both sides by that. Now that looks a little bit cumbersome, and it's going to take you a little bit of practice to be able to put that in your calculator without making a mistake. Okay, but let's try it. I'll give you a second to try that. So I have t is 22.7246, etc., etc. But it said to the nearest quarter year. Well, this is almost 23 years, but if I want to go quarters, this looks like 22 and 3/4 years. Okay, and I'm just going to put a dot there because it's approximately. Okay. All right, so I will give you some of those questions. Those are kind of maybe more basic because compound interest is a formula that you might have seen before. What we'll do now is we'll start going into some of the other formulas, and basically what I'm going to tell you is any formula with a variable in the exponent is fair game. So basically the way this will look, if we do this example here, you're given a formula, never seen it before, but you'll notice there is a variable in the exponent. And so you'll have to interpret this question by reading what it gives you for information. Okay? Let me just quickly go over one thing. If you have an exponential equation and whatever is in the exponent is greater than 1, right? If you think about that, that's going to be an equation that grows. If whatever's in the variable here is less than 1, between 0 and 1, you're actually going to have a decreasing equation. Okay, so this is what we call growth. This is what we call decay. Decay means getting less. Okay, you should keep that in mind so that you kind of have an idea what's happening. All right, so here it says if cabin pressure in an airplane is less than 70, passengers can get sick. So to the nearest kilometer, at what altitude is the atmospheric pressure? 70. So 70 will go in here. So I get 70 is 101.3. Now if I look at this, here, I actually made a mistake. Let's just go back up here for a second. The growth and decay is not in the exponent, sorry. It's in the value of k. Okay, I forgot. I didn't make that clear. This is back, we, earlier we had this. We had a to the x, and we talked about if a was greater than 0, you're going to have a graph that grows. Okay, if a is between 0 and 1, it decreases. Okay, so I know that here it says k, it's the same idea. So let's go back here. What kind of graph do we have? Well, the value that has the base of the exponent is less than 1, so this is a decreasing graph. Okay, this is asking when does the pressure go from 101 to 70? Okay, at what altitude? So we have to figure out what h is. Okay, what kind of equation is this? It's an exponential equation. Bases can't be made the same. You take the log of both sides. Okay, so if I take the log of both sides here, it's going to be a little harder than it has to be. Instead, I want to divide both sides by 101.3. Okay, so I get 70 over 101.3 is 0.88 to the power of h. Take the log of both sides. And that lets me bring the h to the coefficient. And then to get h by itself, I'm going to divide both sides by log of 88, or decimal 88. Okay, so those cancel out, and h is, well, let's try it, log so the height, or the altitude, is 2.891, what? To the nearest kilometer. So this is kilometers or kilometers, and so if it's to the nearest kilometer at about 3 kilometers of height, people will get sick. Okay, so that's sort of your first taste. Now there are some more. So again, here is a formula. You can see there's a variable in the exponent, and it explains what everything is. You have to be able to figure out how to solve this. Now, here's the problem. Some of these equations you may never have seen before. So my advice to you is, if I was really wanting to prepare for this, I would want to do all the questions in the homework to make sure that I've seen as many as I could. All right, there's one on earthquake, the Richter scale, there's one on pH levels, there's one on decibels. These are all exponential equations. Try to do them all. Okay, and the reason for that is each one has a little trick. In this one, here's the trick, the value of I. The value of I, just like in the previous question, like 2 previous ago, is I divided by N. Even though there's just an I in the formula, you actually have to do I divided by N. Okay, so that's going to be the little trick here. So it gives these questions, if it asks you to use a formula, it will give you the formula. So let's start right off by just writing it. And then we'll see if we can figure out where everything goes. So this formula has to do with money. Okay, if you read it, it says when a series of equal investments is made. Okay, so investment, in other words, you're putting in money at equal time intervals, and then there is interest. And the question was, what will the investment be worth? So FV is final investment, or the final value, or future value. Okay, so it says determine how many monthly investments of $200. $200 is the monthly regular investment. Let's put 200 there. How many would have to be made into an account that pays 6%? So don't put 0.06 here because it's 0.06 divided by 12, because that's how many payments there are in a year. It's monthly. Okay, N is the number of investments. This is what we're going to find in this case. That's going to be the unknown, because it says how many investments do you have to make. All right, minus 1. And I, again, is 0.06 divided by 12. And we want this to be $100,000. What a great question. So this is saying if I put in $200 a month, how long will it take me to get $100,000? Okay, now how are we going to get N by itself? Well, you kind of got to peel this apart to get N by itself. Okay, so the first thing we can do, if you notice these big brackets, okay, we can get rid of this stuff because it's kind of outside the brackets. Okay, so let's first put that in the calculator. What is 200 divided by 0.06 divided by 12? It's 4,000. So I'm going to write 100,000 is 40,000, and then I have 1 plus 0.06 divided by 12. Okay, so I'm going to divide by 40,000. Okay, so I think this is going to be 2.5. Let's just make sure. 100,000 divided by 40,000, 2.5. Okay, again, I want to peel away the layers to get N by itself, so I'm going to add 1 to both sides. Okay, so I get 3.5 is 1 plus 0.06 to the power N. Now I need to take the log of both sides, because I need to get that variable in the coefficient. That's the way I can solve exponential equations. Okay, now to get N by itself, I'm going to divide by this. Now you could actually put this thing into the calculator. If you want to do that, let's try it. What's 1 plus 0.06 divided by 12? It's 1.005. So if you like putting that in, you know, and it's a nice number, you can do that. If it's a repeating decimal, I wouldn't do it because then you're rounding off. So N is log 3.5 divided by log 1.005. So N is 251.178. But if I want to make the number of payments, N is going to be 251 payments. Approximately. Might be slightly more, but 251 times you're going to put in $200. Okay? Now, just as an aside, that seems like a lot. Like 251 months, that's 251 divided by 12. That's quite a few months. It's 20 years. Okay? But what is 251 times 200? Because if you're making 251 payments of $200, this is actually $50,200. So what this means is if you pay $50,000, you'll end up with $100,000. This is the beauty of compound interest and saving money. All right? If you can learn something from this course, is that you should save some money because it grows for you. Now, sadly, right now, our interest rates are super low, especially with all this stimulus spending by the government. We're going to have very, very low interest rates for quite a while. So it will be harder to save money. Okay, let's try another one. So another very similar equation. Looks crazy. Okay, if we're given that equation, let's write it out. And then we'll figure out what everything means. Okay, this I is outside here. Okay, so what does this mean? Many people borrow money. So this is going to be, instead of saving money, it's paying back a loan. So you have a loan and you're going to make equal payments. Okay, and what we want to do is try to figure out how do we get this loan paid off. So this one says a person borrows $15,000. That's the present value. That's what you're going to owe to start with. And the question is, if I pay $300 a month, how long is it going to take me to pay off this car? Okay, so I'm going to go 1 minus 1 plus, again, the interest rate is 6%, but remember you have to do that over 12 because it's compounded monthly. And then here is going to be 0.06 divided by 12 as well. Okay, so very similar. We're going to peel it away again. Let's do this. 300 divided by 0.06. 0.06 divided by 12. So that's 60,000. So 15,000 equals 60,000. 1 minus, and let's do that 1 plus 0.06 divided by 12. Let's make that a little bit easier. Okay, so I'm going to divide both sides by 60,000. Okay, and what is 15,000 divided by 60,000? This is 0.25. And you're going to have 1 minus 1.005 to the power negative n. So that looks much better. What we can do now is take away a 1 from both sides. So you get negative 0.75 equals negative 1.005 to the power negative n. And I'm going to divide by the negative. Make this both positive. I'm going to take the log of both sides. And that allows me to put my coefficient in front. So divide both sides by log 1.005. And so negative n is going to be negative 57.68. So if I divide by negative, n is going to be approximately 58 payments, even though that last payment is going to be less than a full payment. But you can't just pay 57 times because that wouldn't pay it off fully. Okay, 58 payments, so that's about 5 years. So that's a very typical car loan. You know, if you want to pay for a car and you make monthly payments, they usually are about 5, 6, 7 years. Okay? So, a couple of things. In a few places, like here, I actually use my calculator to come up with a value. If those aren't nice numbers, for example, if this would have been, say, 15 divided by 45, so 15,000 divided by 45, and that gives you decimal 3333, I wouldn't want you to put decimal 33 there. I would want you to leave that as this amount because I don't want you rounding off. You should not round off until the very end. Okay? So only represent as decimals if they're nice numbers. They terminate. Okay, we'll stop there, and we'll continue with these other ones next lesson. So I'll give you just a few to try. Okay, so this can be your homework. You might not be able to do all of them. Do the ones you can, do the ones you recognize, and then you can go to the logarithms handout on the My Site, and there is a lot of work to do there. The word problems are here in the last two, F and G, but you can do all of those already. Okay?